This is the big important video of stats, dealing with chi-squared. You need to either download this PDF and take really good notes, listening, or take your own notes. You're going to want to write down pretty much everything. I'll highlight things that you may not need to write down. So, the 7 steps. This you don't need to write down because I will go through it step by step in the next slides. It's just an overview for you to look at if you want to pause and look at it and read it on your own. But again, you don't need to write it down right now. All right, so what we're going to do is try this problem. So let's say we go out and survey 400 people. They're randomly selected. And we ask them what their gender is. Are they male or are they female? Do they have regular exercise or they don't? So we set up our tallying and we group all the data in our table here. And these are considered our observed values, what we got out from our sample. So the first column is those who have regular exercise, and the second column is no regular exercise. And then we have the males and the females. So I've already done the sum of those rows and columns. If you want to understand this first value here, 110 people are males and they regularly exercise. So I'll just write that on the side. Males and have regular exercise. There's 110 of those people. All right, here is what we are going to try and prove. Are the variables for gender, males and females, and those who have regular exercise, are they related to each other? The variables may be dependent on each other. For example, females may be more likely to have regular exercise than males, alternatively. So we're going to do the chi-squared test. So what I want you to write down is everything except for this. Just write down these. Is gender and exercise related? And then the above information of your chart. All right, these are your observed values. Now we're going to go ahead and do our 7-step process. Number 1, we want to state our hypothesis. This is called the null hypothesis, for short, HO. How you start this is gender and regular exercise, are they independent of each other? They don't depend on each other, one or the other. The opposite is called the alternative hypothesis, H1. And that is that gender and exercise are not independent. They depend on each other. There's a factor going on there. So that's step 1. Step 2 is to calculate the degrees of freedom. So remember how we had those curves going on? And we talked about that in a previous video. We want to calculate that. So here's our formula. Again, you're writing this entire slide down. You will refer to this a lot. All right. This represents the number of rows. So if we go back, how many rows do we have? This is a row, and this is a row. So we have 2 of them. And then we have a column 1 and a column 2. All right. So row 1 and row 2 makes it 2 rows, 2 columns. Simplify it and you get a degree of freedom of 1. All right, number 3. Quote the significance level required with a degree of freedom of 5 and a significance level of 1. So how you read this is 5%. And your degree of freedom, you want to go to number 1. You're going to arrow over This is 3.84. That number is going to be very important later on. So we're going to quote the significance level, 5%. We're going to go out and find that value of 3.84, and we're going to set up an inequality, number 4. We're going to say, is our chi-squared value, when we go out and calculate it with the formula, is it greater than 3.84, or is it less? So that's stating the rejection inequality. Remember how we had that picture, we had that line, then we had the area under the curve? This would be the rejection. All right, moving on to the next slide. Step 5. This is where the fun begins, where we get to go out and calculate that chi-squared value. We've already done this in a previous video, so it shouldn't be quite as difficult. So we have our sums, and I'm just going to go ahead and show you 216 and 208. Remember, you're taking your row total times your column total. So 216 times 208, and you divide it by your entire sample, 400. And this would be what you should have gotten for an expected value. So 216 times 208 divided by 400. And we get 112.32. Then I'm going to do row total again, column total. 216 times 192 divided by 400 people. And our expected should have been 103. So we got 110, and we should have gotten 112. So we're not too far off. 106, and we got 103, or rejection. Okay, so now let's head down and do these last two. 184 times 208, row and column. And we got 95.6 is our expected. And then last one, row times column. 184 times 192 divided by 400. $88.32. All right. Let's go ahead and circle these 4 numbers. These are what we're going to use. If you like this writing better, you're welcome to do so and write down those numbers. All right, so same. All right, now we're going to go ahead and do our calculating of the formula. So we have our observed and our expected. So our observed, $110, and we got 112.32 as your expected. $110, 112.32. Then our next one, 106 and 103.68. Then 98 and 95.68. And last one, 86 and 88.32. 88.32. Okay, So now we've set up our contingency table to find our chi-squared value. So you take 110 minus 112.32, negative 2.32. We will square that number, and then we will divide that number by e. All right, and then 106 minus 103.68, 2.32. Square that number, divide that number by e, 103.68, and we get 0.0519. Then take 98 minus 95.68, square that number, divided by 95.68. (86) minus 88.32, negative 2.32, square it, divided by 88.32. All right, now we'll add up those numbers, 0.0479 in the last column. So we're adding up these numbers here. Okay, I got 0.2169, so I just rounded it to 0.2170. All right, we're about 12 minutes, so I'm just going to pause this one and we'll start it on the next video to finish this problem.